that 6,000 views. 6,000 views, you could get a phone call. All right. It's well over 6,000 views now. Okay, she was wondering about this one. I think we caught her error, but to identify the ions, right? The solid you don't put in there because that doesn't show up in the K expressions. And then you're supposed to write the reactions. So 7.9, or the K expressions. So if you're not sure how I wrote the KSP expression, just you write the reaction, solid going into its ions, and you'll see that's what it looks like, right? And then before you go on, though, you have to realize, oh, you can also write a KW because you have OH minus. So that means we have to add one more thing to our list, H plus, right? Make sense? Yes? Yeah, and every time you have H plus, you have, because of the KW. Exactly, they're tied in. They're tied to each other. Okay. Now there's no other K's. So now we're ready for charge balance.
So, have you changed the...
And right? Now, mass balance is always confusing, but that's why I like to keep an eye on the number of unknowns and number of equations. You don't waste a second thinking about mass balance because you have enough. You have 3 equations, 3 unknowns. Okay. And you have to solve all this stuff. This would be a good one to solve, right? So your review, we can solve that problem or we can solve another one, right? Any general questions? I don't know. I think hard is subjective. Right? I mean, if you've been ready for every single quiz, I don't think this is going to be that hard. But if you're struggling with quizzes, yeah, all hands on labs are 8 a.m. Yep. Yes. Question. Can we use what? Oh yeah, you can. The question is, can you use KB equations? No problemo. However, that's not Dr. Smith's 5-step process. If you do KB, you just cross out this guy and do KBs instead. You can't. Doing both isn't going to help you. You're just introducing one new unknown and one new equation. It doesn't do anything. So that's why I just stick to one or the other. But if you'd rather write a KB than a KA, fine. But it doesn't help you to then write the other one. Good question. That's a very good question. That would be a good conceptual question on a test.
Yeah, that's what was the question about, like?
Conceptual questions. Okay. Oh, I just make them up. Let's see. We're days 13 to 16. Let's see what I could ask you for conceptual questions. Oh, let's just flip it open to here. Yeah, days 13 to 16. So let's open up 13 for conceptual questions. What was day 13? Oh, it was about activities. Okay. What is the activity of, if you have a 0.2 molar solution of glucose, what is the ionic strength of that solution? It's in pure water. What's that? Yes, it's a molecular compound. Are there any ions? No. So there isn't any ionic strength, right? It's not an no charges. There's no. It's not an activity problem, right? Exactly. You have to have a charge to have an activity coefficient. All right. All right. Look here to calculate ionic strength. Right. Look how we're calculating ionic strength. The concentration times the what squared? Charge. If there isn't a charge, there isn't any ionic strength. Okay. Conceptual questions are limitless here. We could ask some questions about giving you. I could give you this table, and say, give me an example of an insoluble salt. What would be an example of one? What's that? Ca. Okay, you can just pick anything in the insoluble, especially in the insoluble area. I don't see any sulfates. Where do you see sulfates? Oh, here's sulfates. Okay, if you want to do sulfate, just pick one of sulfate with one of these guys. All right, if you want to do sulfate, it'd be easier to pick an insoluble one. Then you can name pretty much anything. Put any cation with it. Just don't make it be one of these. All right, iron, aluminum, whatever. I just don't make it one of those. And we had to calculate ionic strength of solutions. What was the quick and dirty way of getting ionic strength? If it was a 1-to-1 compound, it was just the concentration, right? And why, if you have a insoluble salt, that's kind of where this is coming from. If you had an insoluble salt and you dump in, I don't know, like aluminum sulfate, right, that we picked, insoluble salt. I mean, it dissolves a little bit. You can calculate the solubility of it, you know, and do X and ice. But you can make that little X, that solubility, get bigger if you just dumped in some sodium chloride. Why? Yeah, we're adding an inert, something that's not reacting with anything. Why? Why would that solubility go up? That insoluble aluminum sulfate. No. There's a number of ways to explain it, but one way is like dissolves like. I don't know if that really helps you, though. But by dumping in a whole bunch of sodium chloride, the ionic atmosphere, the chemical environment, it's more, what? It's more ionic-like. Now, ionic is an extreme. Ionic is a full charge, right? But it's more charge-like. So, yeah, I mean, that's what you want to dissolve. You want these aluminum ions and sulfate ions to go into solutions. So, yeah, like dissolves like. You make it a little bit more like, not even close, but at least a little bit more like aluminum sulfate. Well, not a lot more. Well, you can calculate it, right? You'd have to make it an activity problem, and we did that in some cases. The solubility went up, but not a lot, but it went up.
That's without changing KSP, right?
You can't change KSP.
I'm saying the question is without changing.
Yeah, you can't change. The only way to change any K, well, that's a good question. The only way to change any K, I don't care if it's KW, KSP, KA, KB, pick KF. The only way to change any K is what? Well, you mess with concentrations, the equilibrium just reshifts, and then it goes back to get the same K. Change pH, that's just playing with Le Chatelier's principle. Okay, I'm going to add some H, or I'm going to do something that interacts, and things just shift to get so that they get back to the same K, whether it's KB, K. So that doesn't work. You have to change what? The only way to change an equilibrium constant. I don't have any. P-Chem people. You might have a hint. We haven't talked about it, but... Oh, there's another PChem person. They're right behind each other. Well, if you add more product, again, that's a Le-Chatelier principle. So that things mathematically, products over the numerator or the denominator, they work out. So you do the math and you get K. So that, I'm talking about changing the K, changing that constant. You have to change the temperature, right? That's the only way to influence K. Okay.
Any K, right?
Any K. Okay. So 13. There's some conceptual questions. What else? How about 14? Any conceptual stuff? Solubility and the common ion effect. So we're playing around with activities again. And all we're doing here is we're doing X and ice again for solubility. It's the exact same thing, except we just had to rewrite our equilibrium constant expressions. Have them cross out the concentrations and just write activities, right? Which still had concentration in it, but we handled everything the same. So we can do some of those. We have some prepared, written in the review. And that's what day 14 was about. And 15. Oh, okay. Now that's getting into the 5-step program, days 15 and 16. What our quiz was perfect for it. It did both, day 15 and 16. So how about this first question? Using activities and disregarding a full systematic treatment of equilibrium. So I want you to use activities. What is the pH of 255 milliliters of 0.029 molar nitric acid with some 0.065 molar sodium chloride in there too? How would you do this?
First, you have to get on the strength.
Yeah. You need ionic strength. Why? You need your mu. Why do you need your mu? So you can get the activity coefficients. Right. That's the game plan. You get this first, so then you can get the little activity coefficient. So then you can do, because pH is going to be the negative log of, you're supposed to replace all concentrations by activities. So it'll be the negative log of the activity, right? The activity of H+. And here's what the activity of anything is, right? Oh, if it's H+, well, then it'll be its concentration times its activity coefficient. And that's why we are after the ionic strength, so we can get what Adriana said, the activity coefficient, so we can plug it into the activity. Okay? See the big game plan? No?
Do you add this to concentration?
Okay. You're ahead of us. We want to get the ionic strength. Usually you can always use that equation. But remember the trick. If they're 1-to-1, just add them up, right? But you can always use this equation if you want. Always, 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 always. Okay. But when it's 1-to-1, because just think of it, you're going to take this, because H is that concentration, nitrate's that concentration, add them up, divide by 2, that's what this thing is saying. So you get the same thing again. Yeah, if it was H2SO4 or any, yeah, forget it. If you have a charge that's a 2 or something, no way. You have to use that equation. You can always use the equation if you want.
So you're adding the 0.0923 plus that.
And that'll be your ionic strength. Yep. Yep. No no charges other than +1 and -1. Yeah. There's no way it's going to be in our table, right? You're going to have to interpolate.
What confuses me is that which one, like, which ions do you like above?
Right?
Yeah, cool. Yes, and your the gamma isn't going to be unturned, so you're going to have to interpolate.
Right, so the only one we're worried about, right, Pablo, is the activity coefficient for H+. And you're right, I'm sure we're going to have to interpolate because there's no way that funky, weird number is going to be in the table. And interpolating, important point, not given. Okay? So make sure you know how to interpolate. So let's go ahead and we can work this one out or not. Depends how comfortable you are on this. So if you see how to do this one, just go on to the next one. Oh, 0.0943. So remember I had my way of doing this, and you guys probably have your way of doing this.
Okay, this is the meaning for 0.1, right?
So you remember when this is how I set up my interpolation. So I write down the one that I know, the one that I don't know, then I write one above and one below, right, from the table, and then you just go ahead and use that equation straight ahead. Okay, remember doing that? Kathleen, you remember doing this? Okay. And I give you the table, right? If you don't have the table, you're going to have to, let's see, I need 0.0943. 0.0943. So I am between 09, it's 0.01. Yeah. 0.05 and 0.1. Yeah, it's going to be between those two. So I'm going to have to be between 0.05, thank you, sir, and 0.1. Pretty darn close to the 0.1, but okay, so that means it's 0.86 and 0.83, right? So these numbers you get from the table, which you'd have for the exam. Okay. And then do the unknown gamma interval. And just remember to be consistent, right? Unknown gamma interval, right? Okay. Over the known gamma interval has to equal the unknown mu interval. These two, since I took these two, those two, right? Over the known mu interval. Okay. So I think you have that one set up, right? Setting them up is the hardest part. I mean, you can finish it if you want, but I'd like to try to set up all these. That's where the hard part is. So how about something like question 2? Yeah. Yeah. Yes. No, you wouldn't, would you? You wouldn't. What are you going to use for the? Because what you need is you're gonna find this one by interpolating, right? And what's this one going to be? What is it going to be? What's the concentration of H? To 0.0293, right? Because it's a strong acid. All right? Because before, we didn't care about anything, the sodium chloride or anything. We'd just taken the negative log of 0.0293 and been done with it. So that's how you'd calculate the pH without activities. But with activities, it's going to be log of 0.0293 times a little fudge factor. Gamma, the activity coefficient, which is what we're trying to find. Yep. Yes, because it's not in the chart. Okay, Natalie? Oh yeah, exactly. You can always use this equation. You could use it twice, or just use it once for put them all in there. Yeah, adding them up. They already gave us concentration, so we don't need volume. We need to have concentration. So in one way or another, it has to be given. You have to figure it out. It'll be there. It'll be just like the homework. The homework never gave you anything else. How would you set up number 2? Ice table, because they want solubility. So don't worry about activities yet, right? Set up the ice table. Whoa, I better slow down here. Right? Can I be putting these dashes in there? Or zeros? Can I be are those zeros or dashes? They are, right? The reason why I told myself to slow down is because they always have some stuff in there. So you got to kind of be careful. But there's no common ion. Right? I'm looking for bariums or fluorines, and there isn't, so I'm okay. Yep. Okay, so then I'll have x and 2x. Okay.
What about the 1.8 grams of solid? Are you going to use that?
Well, did you use it when they said it was a solubility problem? No. It never fell into place. We're doing the exact same problem we did before with solubility. Except we're just not writing concentrations, we're writing activities. And by doing this step too, then I won't screw up over here. So that's important, I think, to write this step, because then I won't screw up on this side.
These both are the same things that KSP. The only difference is the activities, right? That's the only difference.
So now we just got to figure out these activity coefficients. Are you okay? Oh, that's the one after this one? Okay. Let's make sure. We'll have time to get to it. All right. So the whole goal in here is to get our x, because they want to know solubility, but what's that? Yeah, I bet you we're going to have to, because I just randomly made these guys up. So your mu, your ionic strength is what? 0.029. I'm sure if this is an exam or something, I bet you this, I don't know, that would probably be right on the table, right? So you're going to have to interpolate to get your activity coefficients for fluoride and for barium. And just don't forget to square your fluoride activity coefficient when you get it. Okay. So again, you'd have to interpolate. Yeah, because it's ionic strength. Yeah, and that's right. Yeah, so your interpolation table. We had mu on top. We'll stick with that on top. And let's do, I don't care, barium first. And you said 0.029 in question mark. Then the other one, ionic strength and fluoride. And we'll have 0.029 in question mark. And put the one above and below it. So you have to interpolate twice. All right. So that would be like 0.01 and 0.03, that'd be 0.05. Same one here. All right. Then find the activity coefficients for barium at 0.01 and 0.05 and put them in. But I think you can see how to set it up, right? And what you do. Okay. So are you okay with that one? You may not have it done, I'm sure, but at least you see how to set it up. And the big goal, I think, what really helps me is what Pedro said, just do X and ice. Do everything the same as you always did. Except when you write your K expression, just write it in terms of activities. And then if you have something squared, then you won't forget to square it. Okay. General systematic treatment of equilibrium. Okay.
Here's my question on this.
Uh-huh.
It's a strong acid.
Yeah.
So can't we just take the negative log?
We're disregarding activity. Yeah. Why not?
Exactly. Because
It must be something wrong.
because it breaks down into H2O and water.
Strong acid. So, yeah, why can't you just take pH as the negative log of this guy? Because disregard activities. Why not? There's a problem. You have to ask yourself, is this the only source for H+? There's also water. But remember, water, Kw for water is what number? 10 to the negative 14. So that means H plus and OH minus around 10 to the negative 7. So when I make up this question, look where I put it. 10 to the negative 7. So you've got a contribution from water itself now, because this is so dilute. You're right, Kat. If this would have been 10 to the negative 3, 10 to the negative 2, 10 to the negative 1, right? A lot more concentrated. then you could disregard the contribution due to water, but not when it's this dilute. I don't know. I just haven't set it up, but it could be. Let's set it up. We have time. We have about 5 minutes. Set it up.
Okay, so this is my worst part is what it breaks up into. That's the hardest part.
Okay, what I do is, here I would just write H and NO3.
Right.
And then go on to the next. You always follow the steps. If you can write a KW, write it. If you can write a KA, write it. If you can, and then when if you write a KA, you recognize, oh, geez, now I have more stuff. Then you add them to the list. That's how I kind of prefer doing it. Otherwise, you might end up adding in something extra that you didn't need. Yeah, so right off the bat, I would identify just these two guys. Is HNO3 listed?
No.
No, because it's a strong acid. Yeah, good.
But what about H2NO3?
If you can't make HNO3, there's no way you can make H2NO3. Right? You can't grab, because to grab an H means it has to be somewhat basic, and this guy can't even grab one H. No way he's going to grab two. Okay, so then you jump down here, see if there's any KW, KSP, or KA you can write, and pretty much you always look at this guy, and you can almost always write a KA, just not if he's the conjugate base of a strong acid. That's the only time you can't. And so you can't write a KA. But you can write a KW because you have an H+. So that's about the only K. That's the only K you can write. So now we have to add OH- to our list. It's kind of what Miriam said. If we ever have an H+, you're going to have an OH-. If we ever have an OH-, you're going to have an H+. Okay, and I think that's all the K's. And the next thing was charge balance, right? So cations on one side, anions on the other. And mass balance is never fun. Make sure you actually have to go through the energy. And we do, because we have 3 unknowns, only 2 equations. So what could be your mass balance? What's that? Nitrate? 1.4 times 10 to the negative 7 molar is equal to what? Is equal to what? NO3? In all its forms. Well, you look in your list, that's the only one. But it's helpful to add that English on, I think. That, okay, 1 times 10 to the negative 7 molar has to equal, now you can't do the H because the H is tied up with water and you can't do it. You can't do mass balance with OH either because OH is tied up with the water. So 1.4 times 10 to the negative 7 molar has to equal this dude in all his forms. And you look up here, well, he's the only one. So because the only source for this guy is this. That's why it works. Is the solution that we dumped in the water, which is, well, the H's have more than one source, and it's, yeah, H's don't behave, and neither do OH-. I don't think. Oh, this is going to be a quadratic. Yeah. Yeah, you can't, that isn't gonna work. So we're about out of time, but we'll get these back tomorrow during lab, 8 a.m. lab. Time goes so fast when you're having fun.